Okay, here's page 3. These are going to be all no calculator problems. Okay, the whole page, no calculator. Okay, we are given this function, show that the derivative is that. All right, so we've got the quotient function. U is going to be natural log of 2x. So the derivative of that, the derivative of natural log is 1 over 2x, but then I have to multiply it by the derivative of 2x, which is 2, and that just reduces to 1 over x. Whoa, that's kind of crazy. All right, the other function is x. The derivative of that is equal to 1. Oh, that's pretty simple. Crisscross applesauce, I get x times 1 over x minus 1 times natural log of 2x, which is natural log of 2x, all divided by b squared. b is x squared is x squared. Okay, and then this simplifies, the x's reduce out, so I'm left with 1 minus natural log of 2x over x squared, and voila, we are already there. All right, consider the function k sine x plus 3x, where k is a constant. Find the derivative. Okay, so k is just some number that we just don't know yet, but it's just a number. So when we take the derivative, we keep the constant, and we take the derivative of sine, which is cosine. And then the derivative of 3x is 3. So there it is. That's the derivative, where k is a constant. Now, when x is equal to pi over 3, the gradient of the curve is 8. So the gradient we get from doing this, and they're telling us what x is, so I can put that in here. So I know that k times the cosine of pi over 3 plus 3 has to equal 8, because that's the gradient. That's the slope. When x is pi over 3, the slope is 8, and this equation gets me the slope. This is the slope function. The first derivative is the gradient function, also called the slope function, gets me the gradient, or also known as the slope. All right, so let's solve this. I need to minus 3, so I'm left with k cosine of pi over 3 is equal to 8 minus 3 is 5. And now I need to get k by itself, I'm going to divide by cosine of pi over 3. So I get k is equal to 5 divided by cosine of pi over 3. So now let's use my unit circle. Pi over 3, this would be 1626. It would be right here, so that's 1/2 is my x value. I don't even care about my y value, but that's square root of 3 over 2. Okay, so the cosine of pi over 3 is 1/2. So I get 5 over 1/2. Change that to 5 times the reciprocal, which is equal to 10. So k is equal to 10. There you have it. Right, next question. Given the graph, sketch reasonable graphs for the first derivative and the second derivative. Okay, the first derivative, what I do is I find where are the slopes equal to 0. The slopes are equal to 0 at the maximums and minimums, and if we had a stationary inflection point, the slope would be 0, but we don't have any of those. So remember, the first derivative is the slope function. So if the slope is 0, then y is 0 off for the slope. Y is 0 for the slope. Y is 0 for the slope. Now, the slopes right here are negative, so that means I'm going to be coming up this way, negative y values. From here to here, my slope is positive, and so it's going to go up, and it's going to come back down here. And that doesn't look very smooth, but you get the idea. From here to here, the slope is negative, so I have to have negative y values. Notice I got to come back to my x-axis because the slope is 0 there. And then from here to the right, my slope is positive, so I need positive y values. Okay, that's pretty ugly. It says use different colors. Okay, this clearly is not an IB test question. It wouldn't say use different colors because you are only allowed to use blue or black pen, that's it, on the IB exam. So this is like a fake IB question, but that's okay. We'll do it anyway. So here is my first derivative, okay? My first derivative, so f prime of x. To do the second derivative, I do the same thing, but starting with the first derivative. So where does it have its maximum and minimums? Where's the slope 0? The slope 0 there, slope 0 there, that's it. Coming up to that slope of 0, I have positive, so I'm going to have positive y values. Then it's negative y values until I get to here. So negative y values. And then to the right of this minimum, I have positive y values. So it's going to go back up. Okay, so again, that was pretty darn ugly. Let's get a pen and try and clean it up. So I'm going to come down. I don't know how far down it's going to go. There we go. And that's my second derivative. All right, that was page 3. All done.